We're going to go over a little bit of vocabulary that your quiz is going to be talking about because it's going to rephrase some things. And then we'll go into the next type, which is finding zeros of functions. In other words, we're going to be solving. So if we go through, again, a couple of definitions here. Your first definition is going to be factorization. A factorization, all that means is that you're going to take an expression and factor it. That's all it means. It's just a very, very formal way of saying that you're going to factor something. So for instance, they might ask you, what is the factorization of x squared minus 12x minus 28? All they're asking you to do is factor that in that question. So how do you factor that? Yeah, that was an actual question. Yes. AC method. So you should be looking for GCF, and I'll have one. AC method. So my A is 1. 1 times negative 28 is negative 28. What's my question? And
plus 4 equals negative 12.
and then what does that? Negative 14 and 2 is correct. Now what?
And you put it in fractions.
Put it in fractions, so I have a 1x, 1x. Remember, you bring a with both. Negative 14, 2. Don't forget to see if it reduces. This one does not. So what are my two parentheses?
1x is 14.
And
1x plus 2.
remember, you can put the 1x's there, that's fine, or just write the x's there. That's fine as well. And then remember that these two pieces are factors. So the whole thing is the factorization of it. The individual pieces are the factors of it. That's the two vocabulary words that your quizzes are going to use. Does that make sense for that? Like I said, I think you have 3. That's all you're doing is factoring it, and you have any of the methods. Okay? All right. Can I erase this?
Nice.
Not yet.
All right.
No. Okay. Okay, definition number 2 is a little bit new. And that is the zeros of the function. When they ask you for the zeros of the function, they are going to be asking you for the answers. And typically, that's when our equation is set equal to 0. So if we're finding the zeros of the function, again, those are the answers, and that's typically when our equation is going to be set equal to 0. Sometimes you have to solve it. Sometimes you have to go ahead and set it equal to 0. So those are going to be the 2 examples that we do for this, and then we'll be done. So example number 1. We'll state to find the zeros of y equals 3x squared minus 17x plus 10. if they're telling you to do that, this one's a little weird in that I have a y, right? On your assignment today, instead of y, they're going to have an f of x there. So it makes it kind of weird. But all you do when you're finding the zeros is take this piece and set it equal to 0. It doesn't matter whether that's a y or that chunky little f of x. You completely erase it and replace it with a 0 when you're finding the zeros of the function. Good so far? All right, so then once I have it set equal to 0, so if we are equal to 0, then we're going to factor and solve. So in other words, I'm set equal to 0, which means I'm going to completely ignore that side. And all I'm going to do is look at the right-hand side. And when I look at the right-hand side, I'm going to factor it just like we normally do. So what should I look for first here? Do I have one? No GCF, so now what? AC, so multiply 3 times 10 gives me 30. Ooh, that came out nice. 30. And I ask what multiplies to give me 30, but if I add, I get negative 17. Negative 15 and negative 2 is correct. I'm still continuing with AC method, so I'm still ignoring the left-hand side. Don't forget to bring the 3 down with both x's. Don't forget to write the negative 15, negative 2 below both. And then finally, the whole purpose of doing that is to go ahead and reduce. So 3 over the 15 reduces to 1 over negative 5. Which means what are the two parentheses on this side?
3x minus 5.
X minus 5 because it canceled. And then
3x minus 2.
now I can finally acknowledge that I have another side. Your homework for tonight, not tomorrow, but your homework for tonight is actually going to start you here, meaning when you're already factored. Okay? When I'm here, what you did is you took an equation here that the only way you could really do this is to try to plug in x values and see when this equals 0. That's what you're finding. Which normally when we try to sort of plug and chug like that, we only find one of those answers. We don't find them both. Okay? So that's not really a good way to do this. But if I factored it, what I'm left with is this parenthesis times this parenthesis. So let's sort of shorten this a little bit. If I have some number times another number, and I tell you that that equals 0, then what must be true?
0 times 2.
Huh?
0 times 2.
Well, they don't both have to be, right? I could just have 0 times like 8, right? So then you're correct. One of them has to be 0. Either the A, the first one is 0, or the second one is 0. But one of them has got to be 0 if I'm multiplying to make 0. Does that make sense? So if I take that back to this, and I'm telling you that this big chunky A, so to speak, and this big chunky B, so to speak, they're multiplying together and being 0, then either the x minus 5 is the one that has to be 0, or the 3x minus 2 is the one that has to be 0. Which means now I can solve each piece to see when the first one will go to 0 and when the second one will go to 0. Zach, you still with me?
Yeah.
Are you sure?
Pretty sure.
Yeah. Pretty sure? Add the 5 to both sides and I get 5 for my first answer. Add the 2 and then divide by 3 and I get 2/3 for my second answer. Which means if I go all the way back up here and I plug in 5, you should get 0. If I plug in 2/3, you should also get 0. Any one of those two answers will make that entire thing turn into a 0. Are we good so far? Like I said, you'll have to do this from start to finish tomorrow. Tonight, it's going to take you from factored form down. Cannot erase? Not yet. You're good?
Yeah.
All right. Last example. So example number 2. 2x squared minus 17x plus 45 is equal to 3x minus 5. This is one that's not set up with the y, but it's still done the same way. So if they ask you to find the zeros of the function, they're still asking you to be able to solve it to be 0. The problem here is that I'm not equal to 0, and I need to be. So if I'm not equal to 0, that means that we have to fix it so that it equals 0. Oh, sorry, I forgot this one. There we go. Okay? So we're going to fix it so that this side equals 0. Which means, what do I have to get rid of over here if I want to make it 0?
The 3x and -5.
So how do I get rid of a 3x?
By
Subtracting it, because you want to make it 0, right? Garrett, you still with me? Sure. All right, so 3x, if I want to make that 0, I have to subtract it. What do I do one side? I have to do the other side. What am I subtracting 3x from, though?
-17x.
Because they are alike. They both have x's. All right, now we're going to do this in the same step. Are you ready? I need to get rid of a -5. How do I get rid of -5? Who is the 5 going to be added to? We're in Algebra 2 now. We can do 2 steps. Add straight down. The 2x has nobody to add with, so I have 2x squared. -17 minus the 3 gives me -20x. 45 plus 5 gives me 50. 3x's cancel. 5's cancel. I'm left with nothing, which means I'm left with 0. Are we good so far? Now I'm equal to 0, which means now it's the exact same thing we did before. So we're going to ignore the 0 side for now. How do I factor this?
GCF.
What is my GCF? 2. So 2 comes outside. And then I have x squared minus 10x plus 25. Now what?
1 times 25.
Yep, 1 times 25 to do AC. What multiplies to give me 25? But if I add it, I get -10.
-5 and -5.
-5, -5. Set up my fractions, so I have 1x over the -5's. I cannot reduce, so I'm left with x minus 5, x minus 5. But these are the same thing, yes? So I can write that as x minus 5 squared, because they're the same parentheses. All right, so let's examine this as far as what we were talking about before. This is telling me that I have 2 times whatever that is equals 0. Which means which part has to be 0? The x part, the x minus 5. Because 2 is always going to be 2. The only way you're going to get a 0 is from this x. Does that make sense? So your next step is to set the x minus 5 equal to 0. Add the 5, and I only get one answer this time. And that answer is 5. Again, the 2 has no issues because the 2 doesn't have an x. Now here's a what if, and you don't have to write this on your notes. But what would happen if I had 2x here? Then could I make that piece be 0? Yeah, so that would have to come down also along with the x minus 5. It's the fact that the 2 does not have an x, which makes it sort of not going to send anything to 0. Questions with those two? All right, so if you take out the assignment from yesterday,